So on number 7, first thing we need to do is identify our LCD, and our LCD is whatever appears in the denominator. So here our LCD would be x plus 5 and x minus 6, because those are the only things that appear in our denominator. So what I'm going to do is multiply each term by our LCD. So I'm going to write x plus 6, or excuse me, x plus 5, x minus 6. And this one by x plus 5, x minus 6. So what happens is all of our denominators should cancel out. So on the left side, the x plus 5 and x plus 5 cancel out. So we'll be left with an x plus 6, doing it again, x minus 6 times an x plus 4 equals, and then on the right side, the x minus 6's will cancel out. So I'll be left with an x plus 3 times an x plus 5. So now we're just going to solve this like a normal equation. So I'll distribute. So distribute the x and the negative 6 will give us x squared plus 4x minus 6x minus 24. And the same thing on the right side, we'll distribute the x and then distribute the 3. So we'll get x squared plus 5x plus 3x plus 15. Combine like terms, so x squared minus 2x minus 24 equals x squared plus 8x plus 15. I'll subtract an x squared from each side, so those will cancel out. So negative 2x minus 24 equals 8x plus 15. Subtract 8x from each side. So I get negative 10x minus 24 equals 15. Add 24 to each side. So negative 10x equals 39. And then divide each side by a negative 10. So x equals negative 39 over 10, or if you write negative 3.9, either one of those is fine. 8, first thing I want to do is factor that denominator. So that's a factor sum, two numbers that multiply to 12 and add to negative 7. This would factor into an x minus 4 and an x minus 3. So then I need to identify my LCD to solve. And my LCD is anything that appears in the denominator. So the only things that appear in our denominator are an x minus 4 and an x minus 3. So I'm going to write x minus 4, x minus 3 next to each of our terms. So x minus 4, x minus 3, x minus 4, x minus 3, x minus 4, x minus 3. So now what I'm going to do, cancel out terms. So for my first one, the x minus 4's cancel out. So I'll have a 3x times x minus 3 equals. On the next one, the x minus 3's cancel. So I'll have a 2x, x minus 4, plus, and then here, both the x minus 4's and the x minus 3's cancel. So I'll just have a 6. And then we'll distribute. So we'll get 3x squared minus 9x equals 2x squared minus 8x plus 6. And then we want to make it equal 0 to factor, and we want our x squared term to be positive. So yes, we can subtract the 3x and add the 9x, but what I'm going to do is I'm going to move everything to the left, so my x squared term will be positive. So I'll subtract 2x squared from each side. I will add 8x, and I'll subtract 6. This leaves me with an x squared minus x minus 6 equals 0. And then I'll need to factor this. Factor it using factor sum. So factors of negative 6 that have a sum of negative 1 would be a negative 3 and a positive 2. So I get x minus 3 times x plus 2 equals 0. And then I would get x equals 3 and x equals negative 2. So these are my solutions, 3 and negative 2. Extraneous means if you plug it into any of your denominators. So any of these, you would get 0 in the denominator. So if I plug 3 into this denominator, I would get 0 on the denominator, which means that 3 is an extraneous solution. Negative 2 whenever I plug it into any of my denominators, I will never get 0 here. So x equals negative 2 is not an extraneous solution. All right, so identify all asymptotes and wholes. So to do this, we need to factor each. So we're going to factor the numerator and factor the denominator, and both of these are SAM. So on the top, I'm looking for factors of negative 15 that have a sum of 14, and that would be 15 and negative 1. So this will factor, because it's a 5 in front, a 5x plus 15 and a 5x minus 1. And then this first parenthesis can reduce by 5, so I get x plus 3 and 5x minus 1. So that's my numerator. I'll write it over here. For my denominator, this is also a SAM. Sorry about that. So the bottom will also be a SAM, so we multiply the 2 times 3. So we're finding factors of 6 that have a sum of 7, which would be 6 and 1. So this would factor into 2x plus 6 and a 2x plus 1. And then again, we can reduce the first parenthesis by 2. So we'd end up with an x plus 3 and a 2x plus 1. So we get an x plus 3 and a 2x plus 1. And the x plus 3's will cancel out. So we'll end up with a 5x minus 1, 2x plus 1. So your vertical asymptotes are numbers that make your denominator equal 0. So we set our denominator equal to 0, so the 2x plus 1 equals 0. So 2x equals negative 1, and x equals negative 1 over 2. So x equals negative 1 over 2. To find your horizontal asymptotes, you have to look at the exponents here. So the exponents, now you can look at our original equation or our simplified one. It'll give you the same answer. If you notice, our numerator equals our denominator. They both have the same exponents. So on our first one, they're both 2. And on our second one, they're both 1. Whenever that happens, you're going to take the numbers in front. So this would be y equals 5 over 2. And then for your whole, to figure out where that is the parenthesis that you canceled. So this x plus 3 that we canceled, so x plus 3 equals 0, we'll have a whole at x equals negative 3. Now there is another problem, still review 1, because I didn't put another example of the type that comes after this, but you'll need to know all of these numerator-denominator rules and be able to write equations for them. And then number 10, first thing we're going to do is identify our asymptotes. So we have a vertical asymptote where the denominator equals 0. So my vertical asymptote will be at x plus 4 equals 0, so at x equals negative 4. So I'll have a vertical asymptote here. I'll do the same thing for my horizontal asymptote. Since these are the same degrees, we take the numbers in front, 1 and 1. So for my horizontal asymptote, we get y equals, it's a 1x over 1x, which is just 1. And what we're going to do is make 2 tables, 2 xy tables. On the first one, we're going to pick numbers to the left of our vertical asymptote. So to the left would be negative 5, negative 6, and negative 7. In our other table, we'll pick numbers to the right of our vertical asymptote. So negative 3, negative 2, and negative 1. And then we'll plug these in. So if I plug in negative 5, you have negative 5 minus 1 over negative 5 plus 4. This is negative 6 over negative 1, which is 6. We do the same thing with the next one, so we plug in negative 6. I don't have much room over there, so I'm just going to do it over here. So negative 6 minus 1 over negative 6 plus 4 would be negative 7 over negative 2, which would be 3.5. And you could do this in a calculator if you'd like, or write it out either way. Negative 7 minus 1 over negative 7 plus 4. So this would be negative 8 over negative 3, which gives us 2.7. And again, when we plot these are all just do the best you can. You will have some decimals in here. There's no way of getting around that. So when we connect these, and then we're going to do the same thing with the other side of our equation. So when I plug in negative 3 into my equation, I get negative 3 minus 1 over negative 3 plus 4. So this would be negative 4 over 1, which is negative 4. Negative 2, so negative 2 minus 1 over negative 2 plus 4 would be negative 3 over 2, which would be negative 1.5. And negative 1, so negative 1 minus 1 over negative 1 plus 4 is negative 2 over 3, which is negative 0.67 or just 0.7. Plot these points, and remember, once you plot them, you can't cross your asymptote lines, you just kind of follow them. All right. So if you guys have any questions, you can send me a message on Canvas or through a Remind or email. I will be available all day and probably most of the evening if you are working on this at night. Make sure you complete review 1 as well, and let me know if you have any questions. Good luck. All right, guys, so basically what we're going to do is we're going to factor each of these. So the top left is factor sum. So we're looking for two numbers that are factors of negative 15 that have a sum of negative 2. That would be a negative 5 and a positive 3. The bottom left is again a factor sum, factors of negative 12 that have a sum of positive 1. Those two numbers would be a positive 4 and a negative 3. Top right is a GCF. We're going to factor out our greatest common factor. That would be a 2x, and we're left with an x minus 3. And the bottom right is also a GCF. X squared can go into both of those, and I'm left with an x plus 3. Now, when you're multiplying fractions, you basically can make this one giant fraction. And then anything that's the same on the top and the bottom, you can cancel out. So I can cancel out, let's see, these x minus 3's, these x plus 3's, and then I can reduce these x's, this x, and one of these x's will cancel out. So I'm left on the top with a 2, x minus 5, over an x plus 4. Number 2, top right would be a GCF. So I could factor out a c from there. So leaves me with a c minus 3. On the bottom left, I could factor using difference of squares, which, remember, in your two parentheses, you take the square root. One is plus and one is minus. So it'll be c plus 5 and c minus 5. Top right is a factor sum, so factors of negative 5 with a sum of 4. So that would be positive 5 and negative 1. And then the bottom right again is a factor sum, factors of 3 that have a sum of negative 4 would be negative 3. And again, these should all be C's. Just ignore the fact that I'm making X's. C. And again, with multiplication, you can go and make this one big fraction, and then anything that's the same on the top and the bottom, we can cancel. So let's see. I can cancel out C minus 3's, C plus 5's, and C minus 1's, so that I'm left with C on top and a C minus 5 on the bottom. 3. So first thing we want to do is we're going to keep change flip because we're dividing. So this will stay as 16p squared minus 8p plus 1 over 14p to the 4th. Change this to multiplication, and then flip this last one. So 7p to the 5th over 4p squared plus 7p minus 2. Now I'm going to factor these off to the side and then just erase them because it's hard to write on an iPad. So top left, we're going to factor this using SAM. So we have to multiply 16 times 1. So I'm going to find factors of 16 that have a sum of negative 8. So that would be negative 4, negative 4. So this would be 16p minus 4 and 16p minus 4. And then I can reduce each of these by 4. So the top left will factor into a 4p minus 1 times a 4p minus 1. The denominator doesn't change, the 14p to the 4th. I can't reduce that. And let's see. On the right side, this top does not change, so that 7p to the 5th isn't factorable, so it stays. And on the bottom right, we're going to factor using SAM again, because there's a number in front of our squared term. So we multiply the 4 times the negative 2, so we're going to find factors of negative 8 that have a sum of positive 7. So that would be a positive 8 and a negative 1. So because it's a 4 in front, it'll be a 4p minus 8 and a 4p plus 8, 4p minus 1. And then I can reduce the first parenthesis by 4. So this will factor into a p plus 2 and a 4p minus 1. So then when I look to start canceling things, this is multiplication, so we can make this one big fraction. The 4p minus 1s can cancel. Let's see, the 7 and the 14s can reduce to a 2 and a 1. The p to the 5th and the p to the 4th can reduce to just a p on the top. So it looks like we will have on top p and 4p minus 1, and on the bottom 2 and p plus 2. So let's factor the right side. Top left, keep change flip first. Keep change flip, because we're dividing. So we keep the first one the same. So 9 minus a squared over a squared plus 5a plus 6 times, and then flip this last one, 5a plus 10 over 2a minus 6. So when we factor, this is going to factor into a difference of squares. So it'll factor into a 3 minus a and a 3 plus a. The bottom left will be a factor sum, so factors of 6 with a sum of 5. That would be 2 and 3. So a plus 2 and a plus 3. Top right would be a GCF, so I could factor out a 5. And the bottom right would also be a GCF, which I can factor out a 2. Now when I start canceling things, well, I can make this a big fraction because it's multiplying. 3 plus a and a plus 3 are the same thing, so those can cancel out. A plus 2, a plus 2. Now here, when I look to cancel the 3 minus a and the a minus 3, these are backwards from each other. So imagine factoring out like a negative 1 from here. And then this would become an a minus 3. So now the a minus 3s and the a minus 3s could cancel. So I'm left with a negative 5 over 2. Number 5, first thing I want to do is factor this denominator down here. So this a squared minus 9, x squared minus 9 should be an x plus 3 and an x minus 3. Now, in order to add fractions, we need common denominators. So this right side needs the x minus 3. So we're going to multiply this right side by an x minus 3 over x minus 3. So we'll have 10 x plus 3, x minus 3, plus 4x minus 12. Actually, I'm not going to distribute that yet. So plus 4x minus 3 over x plus 3, x minus 3. And now we have common denominators, so we can combine like terms. Or we can combine these into one fraction of x plus 3, x minus 3. So I have 10 plus 4 times x minus 3. And this x, distribute the 4, so I'll get 4x minus 12. And I'm just running out of room, so I'm just combining these a little bit. And then combine like terms, so on the top I'll have 4x minus 2 over x plus 3, x minus 3. And then I can factor GCF on that top. I can factor out a 2. So I'll be left with 2x minus 1, x plus 3, x minus 3. And that's my answer. Let's erase and give us some room for this one. Same idea, when we're subtracting, we need common denominators. So first thing we need to do is factor. So I can GCF this and factor 2. So just leave with an x minus 6. And this would be a factor sum. So this would be an x minus 6, x plus 2. And then I need to multiply so they have common denominators. So the left side needs the x plus 2. So we're going to multiply by x plus 2 over x plus 2. The right side needs the plane 2 that the left side has. So we're going to multiply by 2 over 2. So we'll have 7x plus 2 minus 15 times 2. Now they'll have common denominators, so we can write times 2, x minus 6, x plus 2. Distribute on our numerator, so 7x plus 14 minus 32, x minus 6, x plus 2. If I combine like terms on that numerator, 14 minus 30 is 16. So this will be 7x minus 16 over 2x minus 6, x plus 2. All right, these questions should look very familiar. They're very similar to what you did yesterday. So if you only needed the front, you can pause it now. Again, all of these problems I'd recommend trying first before. I'm actually going to make a second video for the second half of these questions, for these next 5. All right.